Hi everyone, it's Adam again. So today I'm going to go over complex numbers and kind of where they came from, why they're important, that sort of thing, and how to what sort of questions you'll be asked in the Leaving Cert. Okay, so basically, how do complex numbers arise and what are complex numbers? So a complex number is something that looks like this. Basically, you have a real part. So a real part is just any number that you've seen up until this point is all real. So 2, 7, 2.3, minus 17.4, root 2, pi, all those are real. Fine. This here is the imaginary part. Or complex. Okay, so you can either say complex or you can say imaginary. Okay, so either or. So the complex and the imaginary part basically stems from this I. So what makes a complex? I is the square root of minus 1. It's the number that if you square it, you end up at minus 1. So this is the thing that because you might say, oh, square root of a minus number, you can't have it. Now we're saying you can. We just rewrite it as the letter I. So I is just the square root of minus 1. And you might say, well, hold on, like, when would I ever use this? It could be something if you wanted to solve a quadratic equation. So like this. Equals 0. And you say, okay, I want to know what x value will give this 0. So what are the roots of this equation? You'd say, okay, grand. So using the minus b formula, I get x equals minus b, which is 2, plus or minus the square root of 2 squared minus 4 times 5 times 1 all over 2. So x is going to be 2 plus or minus the square root of minus 16 all over 2. This is 2 plus or minus the square root of minus 1 times the square root of 16. So remember, we can always split up square roots into two separate parts like this. Why? Because minus 16 is minus 1 times 16. So I get x is equal to 2 plus or minus root 16, that's 4. The square root of minus 1, we're now saying is I. So it's I over 2, so it's just 1 plus or minus 2i. So that's the solution. And you'll say, okay, grand, well, that's all fine, but what does that actually mean? Well, if I draw out the quadratic, it looks something like this. So basically what we get is we don't get any roots. And how do we know that we weren't going to get any roots? Because we have imaginary roots. We have roots that aren't real. They are imaginary or complex instead. So basically, imaginary roots mean that they don't exist. And therefore, we have that when you draw out this quadratic, we get this. And therefore, it never hits the x-axis. And therefore, it has no roots. Okay? So that's all. So I'll just do a couple of examples on how to solve equations. So basically, what they ask you is, they say, okay, solve the following equation. So what is the square root of minus 25? In this case, you'd say it's the square root of minus 1 times the square root of 25. This is I times square root of 25, 5. So it's just 5i. So that's how you get the square roots of negative numbers. You basically just have an I in front of it. That's all. Now, another thing that I want to just kind of draw your attention to is that they might ask you to solve this. So this is a quadratic. Typically, when you're working with complex numbers, you use the letter Z. So x and y are for real numbers and then z is for complex. So basically, if they give you an equation in an exam and there's a z there, they're basically saying this is because z can be complex. Okay? So they would say z is an element of C. So x is typically an element of R. So back up here, x is an element of R. So it's all real numbers. Here, you're saying that z can be complex. So now if I solve this equation, I can say, well, z squared is equal to minus 9. So z is equal to plus or minus the square root of minus 9. So z is equal to plus or minus 3i. So that's the solution to this equation up here. So in the same way that normal quadratics have two roots, this also has two solutions. Okay? So that's one thing to remember, that when you're dealing with a quadratic, don't forget the plus and minus when you're doing the square root. Okay? All right. So that's kind of just an introduction into what an imaginary number is and how you can come, how they come about. The next kind of bit is very important. It's the Argand diagram. So this is basically, how do you draw complex numbers? So what you have is, you have your imaginary axis, you have a real axis, and basically you draw 1, 2, 3, 4. So let's say I wanted to draw the number, say something like 2 plus 3i. And I said, okay, where is that on the Argand diagram? You would go to 2, you would go to 3i, and wherever they land, that would be where you draw it. Okay? So the real part goes along the x-axis and the imaginary part goes on the y-axis. The same way, if I had 2 minus 3i, it would simply be down here instead, at minus 3. Okay, so the real part stays the same, it's just the imaginary part becomes negative and therefore it's down below. Okay, so that's the Argand diagram. You have your real part along the x-axis and then your imaginary part is on the y. Okay. Okay, now the next thing that I'd like to go over is just modulus. So it's basically, the modulus is the length. Okay, so modulus is a German word. It basically means size. That's not an S. Size or length. So basically a complex number here, that is its length. So when we say what's the length of a complex number, we're asking what is the length to the origin. Okay, so basically if we go back to third year trigonometry, I can say, well, the height is 3, the length is 2. This length here I can say is L. I can use Pythagoras and say, okay, well, L squared is going to be 3 squared plus 2 squared. So the length, or the modulus, is equal to the square root of 3 squared plus 2 squared. And again here, just to be clear, here when I took square roots, I had a plus and minus. Here I don't. Why? Because it's the length. Length can only be positive. And so technically there is a plus and minus, but I'm saying that I'm not going to take the minus because I'm looking for length. Okay? So that's basically how you do it. So it's just Pythagoras. Okay, that's all it is. Now, the way they'll say it is, let's say z is equal to a plus bi. So z is just some complex number. Okay? If they ask you for this, this is called the modulus of z. This is how they will write it. They will ask you, what is the length of z? Like this. So this is equal to the modulus of a plus bi, which is equal to the square root of a squared plus b squared. Okay? So that's all the modulus is. So the square root simply comes from Pythagoras. That's all. Okay? So in the same way we have this looks very, very similar. Here we had a 3 and a 2. Here we just have an a and a b, and therefore we have a and b here. Okay? So hopefully all that's okay. So just a quick example. They might ask you to find what's the modulus of 3 minus 10i. You would simply say the square root of 3 squared plus 10 squared which is the square root of 109. That's it. You're done. No more. Okay. Same thing. If they ask you what's the modulus of minus 3 minus 7i, that is simply the square root of minus 3 squared plus minus 7 squared. Minus 3 squared, that's the same thing as 3 squared, which is 9. And 49, so it's just root 58. And that's it. So the modulus is just what's the length of the complex number. So how far is that complex number from the origin? The origin being 0, 0 here. Okay? So hopefully that's okay. Now, I'll go on to how to multiply and add and subtract different complex numbers and what they look like on the Argand diagram as well. Okay, so if I add two complex numbers, let's say Z1 is equal to A plus BI and Z2 is equal to C plus DI. How do I add Z1 and Z2? This is a very fundamental thing in this sort of maths, okay? And it's a thing to keep in your head, because it probably will come up. I'll try and find a question in the book. If not, I might go into the exam papers to find one. But basically, what you're saying is, okay, there's two equations always when you're adding and minusing complex numbers, okay? So in this case, you're saying, okay, if I add two complex numbers, you add the real part to the real part and the imaginary part to the imaginary part, okay? So in this case, you would add A to C. That's your new real part. Plus B plus D I. So again, this is imaginary and therefore you add the imaginaries. These are both real and therefore you add the reals. Okay? Same way, if I did Z1 minus Z2, I would just get A minus C, B minus D. Like so. So that's it. So it's just if you're adding and subtracting complex numbers, that's all you're doing. Okay? So let's say Z1 is equal to 2 minus 3i and Z2 is equal to 11 plus 5i. Then I can say Z1 plus Z2 is equal to the reals plus the reals. 2 plus 11 is 13. Minus 3 plus 5 is plus 2. Okay, so that's it. And then if I wanted to do Z1 minus Z2, I would simply do 2 minus 11, that's minus 9. Minus 3 minus 5, that's minus 8. And that's it. That is how you would just add and subtract those. Now, the next thing is, how do you multiply complex numbers? So let's say I asked you to find what is 5z1. So what's 5 times z1? You simply multiply 5 by 2 minus 3i. You would say 5 times 2 is 10. 5 minus 3i is minus 15i. Done. Okay. But then what if you said, okay, well, what's 5i times z? So now I have an I in there. You would do the exact same thing. You would say 5i times 2 minus 3i. That's equal to 5 times 2 is 10. I minus 5 times 3 is 15. I times I is I squared. Now, again, just have a quick little think. What is I squared equal to? I squared is equal to minus 1. So in this case, this would become 10i plus 15. Typically, we write the real part first and then the imaginary part either. There's nothing concrete about that. It's just, that's typically what's done. Okay, so this is going to be 15 plus 10i. So that's how you add, subtract, and then multiply complex numbers by a certain constant. Okay? So hopefully that's all okay. Now, how do you multiply complex numbers by other complex numbers? So let's say I want to do z1 multiplied by z2. So z1 is 2 minus 3i. z2 is 11 plus 5i. So what happens? So again, you just use your brackets just like normal algebra. Nothing fancy. Okay, so 2 times 11 is 22. 2 times 5i is plus 10i. Minus 3i times 11 is minus 33i. Minus by plus is minus. 3 times 5 is 15. I times I is I squared. Okay. So this is again 22 plus 10i minus 33, that's minus 23i. Minus 15i squared, that's minus 15. I squared is minus 1. So that's 22 minus 23i plus 15. 15 plus 22, so again add the reals to the reals. So I get 37 minus 23i. Okay? So that's it. That's all. Okay? Okay, am I going to do... So I'm just thinking about what ones I want to do. Yeah, I'm going to do how you divide complex numbers next. And then yeah, okay. So what I'm going to do is I'm just going to pick nice ones just for myself. Okay, I'll do one awkward one and one nice one. So first of all, what if I do 11 plus 5i divided by 2 minus 3i? How am I supposed to solve this? This is a trick that you will just have to learn off. This is a thing that you will not come up with on your own in an exam. You just have to know it. It is very simple. You just gotta, in your head, just say, okay, you know, this is what it is, great. You multiply the top and the bottom by what's called the complex conjugate of the bottom. So basically, the complex conjugate is when you change this sign from a plus to a minus or a minus to a plus. Okay? So remember, I'm multiplying. This thing here is just 1. So I'm not multiplying the fraction by 2, I'm not multiplying by 3. So remember, you want to keep the fraction the same. I want to multiply by something, but I don't want to multiply by anything other than 1. Okay, because if I multiply by anything other than 1, then I'm changing the value of the fraction. I do not want to do that. Okay? So you multiply the top and the bottom by the complex conjugate. So this is called the complex conjugate. So this is the complex conjugate of this. This is the complex conjugate of this. You just change the sign of the imaginary part. So back up here, when I had these two things, this would be the complex conjugate of this. Okay, that's actually really, really bad. Okay, with 2 different color. That's even worse. Okay, what about yellow? There we go. Okay, so this is the complex conjugate of this. This is the complex conjugate of this. Okay, why? Because the imaginary part flips sign. Okay, so it goes from being plus to minus, or it goes from being minus to plus. Okay, so these two are what we call complex conjugates of one another. Okay? Now, why I want to multiply by the complex conjugate will become very obvious in one moment. So again, we get that it's 11 plus 5i, 2 plus 3i. So I'm just going to draw a little line under here just so it makes my life easier when I'm drawing my lines. So again, it's this times this, this times this, this times this, and this times this. So again, just multiplying out brackets as you always would. Okay. Okay, so on top, what do I get? 11 times 2 is 22. 11 times 3i is 33i. 5i times 2 is 10i. 5i times 3i, that's 15i squared. Okay? Now on the bottom, I'll do 2 times 2, that's 4. 2 times 3i is plus 6i. Minus 3i times 2 is minus 6i. Minus by plus is minus. 3 by 3 is 9. I times I is I squared. Okay? Again, I don't expect this to seem obvious as to why I want to do this way at all. Okay? Just bear with me one moment. So on the top, this is going to be 22. 33 plus 10i, that's going to be plus 43i. 15i squared, that's minus 15. Okay, so remember, I squared is minus 1. So it's just 15 times minus 1, which is minus 15. All over. So it's 4 plus 6i minus 6i is 0i. Minus 9i squared, that's plus 9. Hopefully now it becomes obvious as to why I wanted to do what I did, because this now is a real number. So I've changed, it was an imaginary number. Now all of a sudden it's a real number. So now all of a sudden I have it's going to be 7 plus 43i all over 13. This is just 7 over 13 plus 43 over 13. I. And that's it. That's this number divided by that number is just simply equal to this. Okay, and that's it. So now that was a very hard one. But now that we've done it, hopefully it isn't too bad. Okay? All right. Now the next thing that I want to go over is I want to go over how do you plot these in the Argand diagram. Okay? So, okay, will I just do that all in one? Okay, I think I'm going to skip it for a little while and then just do the Argand diagram all in one go and just do one big thing. Or would it be easier to just do it now? Probably could be easier to just do it now. Okay, so I'm going to do how do you multiply. Oh, will I? Okay, I might just do one more thing. I might just introduce polar form and then I'll do it. No, sorry. Okay, I'm just kind of thinking about what would be the best way to teach this. No, I think it's fine. So first of all, adding and minusing complex numbers. How do you do that? So let's say, again, we have Z1, which is 2 plus 3i, and Z2, which is minus 4 plus I. So where do we draw this? So again, okay, I might just get rid of this and make it a bit easier. So all of these boxes are going to be exactly 1. Okay, so 2 plus 3i, so remember this is the real, this is the imaginary. So the real, I go over 2 to here and I go up 3. So that's 2 plus 3i. So Z1. Z2 then is going to be minus 4, so it's backwards. So it's 1, 2, 3, 4, and it's plus 1, so it's 1 up here. So it's Z2. Okay, so basically, if I asked you to add these, the way you do it is you would draw 2 lines. Okay? Like this. And you do what is called, you make a parallelogram. Okay? So you make sure this line is the same as this line. and this line here is the same as this line here. Okay, so this line, it goes to the left by 4 and up 1. So this line goes to the left by 4 and up 1. This line goes to the right by 2 and up 3. So this line goes to the right by 2 and up 3. So that's how I get this up here. And this one, this is Z1 plus Z2. Okay? So that's it. All right? Now, the other way to do it then is that's Z1 plus Z2. If I asked you where Z1 minus Z2 was, basically what you do is you go to Z1, which is here. So I might do this in red. So you go to Z1, which is here. Grand. And then you say, okay, what if I undo Z2? So Z2, you go to the left by 4 and up by 1. So instead, I'm going to go to the right by 4 and down by 1. So this then will be Z1 minus Z2. Okay? And the same thing, if I go to Z2 and say, okay, well, what's Z2 minus Z1? You'd say, okay, you start at Z2. You'd say, okay, what's Z1? Z1 says you go to the right by 2 and up 3. So instead, I'm going to go to the left by 2 and down 3. So I get this one. Okay? So this one is Z2 minus Z1. And you'll notice this and this are just, okay, sorry. But these two things are just in opposite directions of one another. Which should make sense because one is just the minus of the other. Okay? So Z2 minus Z1 is just the minus of Z1 minus Z2. Okay? So that's how you add and minus complex numbers. Okay? If you're in physics, it's just adding and minusing vectors. Okay? Or applied maths, it's just vectors. That's all it is. Okay. So now, what about multiplying? So again, if I just say I have Z1 here, what happens if I multiply it by 2? If you multiply it by 2, the length simply doubles. Okay? So the length, so if this is length L, this is also L. So the total length is just 2L. So if you multiply it by 2, let's say you multiply it by minus a half, it'll just come down here, but it'll be halfways. Okay? So hopefully that's not too bad. Kind of obvious if you draw it out. You say, okay, well, if I double it, then what did I do? I went over how much? I went over how much? Do the same thing again. All right? And then if you do minus a half, then the minus will just bring you the opposite way. So minusing will always bring you the opposite way, as we saw up here. Just goes the opposite way. And then, again, it's a half. So it's just a half length instead of a full length. Okay? Now, if I do I times Z1, this is a very important one. Okay? That basically, if you have I times it, then what happens is it just rotates 90 degrees. Okay, I'll explain this later when we're doing the Myers theorem. I'll probably save that for another video, to be quite honest. But basically, that's all you need to know. All you need to know is that if you multiply it by I, it just rotates by 90 degrees. So the length of it stays the same. So this is L, that's also L. But it's just 90 degrees turned to the left. Very important, to the left, not to the right, to the left. Okay? So that's basically what happens if you multiply it by some complex number. Okay? All right. So then the next thing is to do polynomials and then de Moivre's theorem. Okay, so I might leave that then for the next day. Okay, so I think I'll leave that for the next video. So I think that's enough on complex numbers so far. Okay. All right, I think I'll stop there. So thank you very, very much for paying attention, and I'll see you in the next video.